we expecting any more?
I think one guy is going to come.
Okay. Okay, I think it's time to start. All right, so we'll pick up where we left off last time. I've asked you to go through the exploring model and viewpoint section. Have you guys done that on the answer? The ones that we were working on last week. You guys were here. You were not here last week. Okay. All right. So yeah. So they're okay. Just so that you. Okay. So you see, so in the model, in the module information section, there are Navisworks managed resources files. So these are files that the first four we used to get familiar, to start familiarize yourself with the Navisworks. So I think if you haven't done that, I think I highly suggest that you do this. Otherwise, you won't be able to carry out the clash section to the last one, which we'll do today. So in the meantime, while I do the clash section, you guys have to catch up with the so download the four of them, and the PDFs are handouts, okay, and the zip file are exercise files. So each exercise file corresponds with the appropriate handout, PDF handout, right? Okay. So, all right. So in clash detection, exercise, what you do is you generate a clash report, okay? And generating a clash report needs some, it follows a certain clash detection strategy, right? So what is the purpose of? If you can tell me what is the purpose of a clash detection report? Yeah, but what's the main purpose of it? It's the actual clash is generating that, but the purpose behind doing a clash report. Yeah, I mean, the purpose of clash detection report is to flag any issues before the design moves to another stage, to the following stage, subsequent stage. Because if it moves subsequent stages, there will be something what we call rate of recall of the model. So recall of the model. So when you recall the model, it means there's something wrong, and it's difficult when you exit a stage, and then you go back to that stage again, because when you exit that stage, it means the workflows that have been set up for that work stage and the deliverables have already been achieved. So is difficult because you would have an approval workflow to move from one stage to another, because you need people who are responsible for approving the model. They approve the model, and then there's a consensus, which means that all the parties agree on that version. When you exit that, it's difficult to go back to this, especially where the client has agreed on a few things. So clash detection report avoids that. Okay. So before you move to a stage where you pass your, let's say, your model or construction documents to contractors, subcontractors, you want to make sure the building that you deliver, or you're giving them is problem free, right? Problem free, because because if they face a problem on site, it's an issue. The problem will become more complex to fix, because it will cost money, and it will cause the project or the site to come to a halt, and then so there are different problems. So clash detection report avoids all that. So it makes you want to make sure that the models are federated and are clash free, basically. All right. So to generate the clash report, step one. Okay. So clash report is always generated between two design models. Okay. You would have two or more. Okay. There's no one. You cannot do clash detection with one, because it has to be another discipline. And a building as we use it, all right. Buildings as we use them, they exist in several disciplines exist in the same model, because we perform a function using different systems. For example, I'm saying here, I'm standing up in here. There's the mechanical ventilation unit is running, which provides, or heating is running. That's a function. All right, so it delivers a function which is in comfort. I'm standing on this floor slab, which I'm using the structural element to stand. All right, or it could be structure. It could be something else. All right. So you're using different disciplines in one model. So they exist. So the clash detection needs to involve all the disciplines that are being used. Okay. As I said, clash report is always generated between two design models. Okay. Using example. This is a software that does the clash detection. The software that we use for this module. There are other software that you can find in the market. For instance, there's a famous one they use a lot. It's called Solibri. Solibri is a software similar to Navisworks. It does the same thing. It's a clash report. Some say Solibri is easier, but I've always used Navisworks, so because it's part of the Autodesk family. So the first step involved uploading the existing design model of one discipline into Navisworks software. Okay, so we could choose any two design models. Okay, to generate possible clashes between them in the coordinated model. If you remember, we've done clash detection on BIM 360 online clash detection. So it's an online tool which allows you to do clash detection. This one, Navisworks, is a software, so you can do local clash detection. You don't have to be online to run it, and it's a bit more detailed in here. Okay. So step two, in the second step, we need to load the second design model. Okay, which we need to coordinate with the first independent model. Okay, let's for instance, if we had an architectural model, so that would be the first independent. Okay, and the second design model could be structure. All right, so structure needs to be loaded along with architecture so that you federate them together. One of the issues that happen during model appending is the origins. All right, the what do you call it, the shared coordinates. Okay, so the shared coordinates sometimes they don't align because they use a different they mess up. For example, the shared coordinates, which is the the base is 0, 0. So coordinates may be different from let's say the structural design team is working on a template that has different coordinates than the architectural model. So if you don't share the coordinates, your model will not be 100% aligned on the top of each other. So it will be slightly offset. So when this happens, you cannot generate a clash report because you need to fix the coordinates and you need to append it. Sometimes what people do is they take a reference point, let's say a column in grid, A intersecting B, for example. You take that and you attach it to the same area where it is, so that you keep. I think you've done this in AutoCAD. So when you copy something, you have to take a reference point so that you can place it on the top of each other, so that it aligns. Okay. Similar thing. So shared coordinates are important for this. These two separate models are merged into a single model. Okay. For the further clash detection process. Okay. Step 3. So next steps involve starting the clash process. Okay. Through choosing these two models from the loaded models. Okay. Naming this report and running clash test. So as simple as that. Step 4, after running a scan, okay, the system gives us the potential clashes between these models with status details, right? So description and condition according to their level, right? It provides the status as new, active, approved, and resolved, okay? So when you go through the clashes, you start doing, you signal this as a new, if you're rerunning the clash. Active is still active, okay. Approved, which means it's done, and then resolved. Can somebody tell me why we have approved? Why do we have approved? What's the purpose of approved? What's the difference between approve and resolve? If we've looked at this, have we looked at the false positives and false negatives? Last time, no? All right, so okay, so I thought we covered this. It comes in the next slides, okay? We'll come back to this. So as I said, approved and resolved, which is essential when rerunning the test after design alterations, okay? All right, step 5. Remember the steps because we're going back, and then I'm going to allow you to work on the exercise itself, okay? So at the last stage of this process, it allows us to select all the details we want, okay, to include in the clash report, okay. We can choose from the available options for the format of the report. It could be HTML, PDF, etc. Okay, it could be any type of file that you can generate. Okay, depends on what you need. I generally ask the students to generate an HTML-based flashes. Because it's easier, I can open it from my web browser, and I can see the clashes with the images with the file. Okay, so that's HTML file will be one subcomponent of the second submission. So once we generate the clash report, by clicking on the right report, okay, it generates a detailed report and individual images. All right. It will generate you individual images, so screenshots of each clash. Okay, you'll see it. All right, showing those clashes in 2 designs. Okay. So as I said, remember when I spoke about algorithms for clash detection last time? So these are sphere collision, bounding box collision, and the shape collision. These are the algorithms, different algorithms they used for developing the clash detection in construction. This one is a rule-based clash section. That's Solibri. Okay, that's the interface. Okay, we're not going to use Solibri, but just in case that when you go into industry, Solibri is one of the software that does clash detection, and many companies use it. This is the interface of the model checking. So this is how they check the model in clashes. That's an interface of the software, right? Contemporary clashes. Contemporary challenges and clash detection, or clash avoidance. Sorry. I talked about clash avoidance last week. When you employ strategy to avoid clashes happening before you do so. Clash detection is the last stage where a BIM manager gets involved, right? So the BIM manager obviously, apart from setting up the CVE and workflows and standards and conventions, they have a role of, there's a different naming for that person. You may call them BIM coordinator, right? So BIM coordinator is the guy or the person, the individual who does the coordination, right? It's called a BIM coordinator. Most jobs in industry nowadays require a BIM coordinator, right? They need someone to coordinate their models. They need someone with the skill set necessary to be able to carry out that task. So BIM coordinator does the clash detection and flagging issues and signal. Have you guys seen in BIM 360 when you flag issues and working with templates and workflows? This is exactly what BIM coordinator does in the industry. So you've had a very tiny experience of what industry does. Exactly what you've done. It's just the model is different, the project is different, but the exact same way of working. So clash avoidance is a proactive strategy. So it does not it prevents it resolves the problems before the actual clash detection happens, before it happens. Okay. So with that in mind, the BIM coordinator will have less clashes to resolve, because obviously if you do clash avoidance strategy, and that obviously you've got different strategies to have in place, you're avoiding as much clashes as possible. So you're resolving clashes as you go forward. Okay, so this is a clash avoidance. It's proactive, so it does not wait until the models are passed on to the coordinator, and then you will receive notifications to recall your model and change stuff. Okay, so instead of doing this, having one person to aggregate the models, why don't we work when we apply clash avoidance during the WIP, work in progress, among design teams, and we can actually start reviewing as we make changes. Okay, for example, I'll give you one best practice is, if you're working on a WIP design collaboration folder, which means that you still haven't issued your models or design package, okay, to a shared folder. Shared folder will have other disciplines, to work together. Okay, that's a folder which is the common folder for disciplines to merge. Okay, so let's say you're working on version 7, V7 or V8, okay, of the model, the architectural model, and before you arrive at so you've gone from version 2, 3, 4, 5 until 7, okay. So along these versions, every time you do a version, you can set up a workflow that every time there's a version issued, it gets sent. It enters a design review, and from that design review, when it's approved, it goes straight to shared, and then there's someone who's involved in shared using design collaboration to aggregate the models and do clash detection, and then send the report back. So before you move from one version to another, you make sure that their version is clash free. Okay. And then at the end, you will end up with very minimum clashes. So the workload will be less the coordinator, which means that there's a higher chance that your model is will be 100% accurate during construction. So in order to do this, it needs practice. Okay, that's what I meant earlier when I said, can you guys differentiate between approved and result? Okay. In class section, we have terms like false positives, okay, and false negatives, and rate of recall. These have important meanings, okay. Can you guys tell me what do you make of these three? Okay. Okay. Can I give you 5 minutes to think about? Maybe you can do some search and tell me. Okay. So these three terms, okay. Take 5 minutes, yeah? Okay. Okay, so all right, so false positives, yeah. Anyone? False positives?
It says it's an error in binary classification, which indicates there's a presence of no problems when there is actually.
Yeah, exactly. So we'll see the meanings. False negatives. Anyone? Yeah, the opposite. Yeah. Rate of recall. Rate of recall? Anyone in the back? Rate of recall? Any engagement? Majora? Rate of recall? Gabby? Okay, so rate of recall is the frequency of recalling a model. So how frequent you call the model back to you. Is that clear?
Is it measured in, is it written in percentage?
Yeah, you would give a percentage of how frequent the model is recalled to you. For example, if there is a weekly flash report is generated weekly, so there's a chance that you would have a frequency of weekly recall. So weekly recall. So the model coordinator asks you to change stuff. Then you take the model. Do you know what the recalling the model, because it exits from your working space, and it goes into a space where there's coordination. Okay, the coordination is not the person who issued the model. It might not necessarily be the originator, the model originator, who does the coordination. It's a different person, which means that, however, that different person has no authority. There's no authority to make any changes in the model. If they request something, they need something changed, they ask the originator who issued the model. Okay, so that's what we call it rate of recall. So the originator recalls the model, changes, and send it back to shared folder.
How much is the structural engineering involved in the testing?
It depends on the number of clashes. If the clashes, let's say the architect wants, because the architect are the decision makers, okay? If they want something to be moved, so that there's no impact on their architectural design, they ask the structural engineer to move it. So when they ask the structural engineer to move it, the BIM coordinator asks the structural engineers to recall the model, make the changes, and upload them again. So it depends. There's no fixed percentage. It depends on the complexity of the model and how collaborative the team is. All right. Rate of recall changes significantly from one project to another. So there's no standard rate of recall. It depends, as I said, on the level of collaboration involved. Is that clear? Yeah. Is that clear? Yes. No. Okay. So, an undetected clash is false negative, right? Something like you guys said, it goes undetected, right? While a wrongly labeled clash is false positive. Okay, false positive means that there's a clash, but it's not a clash. That's why you have approved and resolved. Okay, the reason why I said I'm going to go back to the difference between approved and resolved is that when there is a wrongly labeled, you can approve it as a false positive, and it doesn't become a clash. All right, so that's approved. Okay, resolved, no. Resolved is resolving the actual clash. Okay, that's the difference between approved and resolved. All right, so when a clash occurs, the model should be recalled by the designers or modelers. All right, that's the rate of recall. Or in practice, the clash detected would alert designers, all right, the model coordinator, about the identified clash, after which they should recall it if it is needed. It is indeed a clash. Okay, so if it's a false negative, all right, and you say, oh, hang on a second, there's a false negative. You after review, you're bringing the model. you notice that there's a clash that is not signaled. Okay, so what you signal it, and then you ask the person or the originator. Sometimes it could be two, right? As I said, designers S. It could be more than one, right? If it's more than one, for example, two, you got the mechanical, because the clash happens with two disciplines. Okay, so at least two originators would be involved. Okay, so the discussion will go between the designers who actually have that clash. Okay, if it's an MEP, if it's a mechanical versus electric, which means that's an in-house design team. That's for the MEP team. Okay, they'll resolve it because they have an internal procedure. If it's a cross-discipline, let's say MEP or structural, these two, you will have two. The structural team will appoint someone, or who's the guy who issued the model. We'll go into discussion with the MEP. Depends on what the sub-discipline is. If it's electric, they will have discussion with the electric team. However, electric team will not approve anything until the MEP is satisfied. The MEP team is satisfied. So there's an internal discussion and a cross-team external discussion. Okay. So this is how collaborative team should be. Right. And then if there's a clash, they would just ask the originator to recall if it is a clash. Okay. As I said, the frequency clashing the model is sent back to its designers is known as the rate of recall. So that's how often the clashing is back and forth. So is back to its designers. So I send it back to you because the originator. That's one rate of recall. Okay, and then this is how you define rate of recall. Okay. Challenges and best practices. Okay. There is an inverse relationship between rate of recall and precision of detected clashes, depending on whether manual or automatic bin clash detection is carried out. Okay. Now, automatic and manual, you can go one by one, signal them. You could end up with 2,000 clashes. There's no way you can go one by one. All right, so you do automatic clash detection. So what we'll do, we'll send the clashes to the team automatically. There's also a cost and time aspect to how clashes are detected. Okay. Having experienced designers carry out manual coordination would lead to more precise results. Okay. So when you have someone with a very large experience, wealth of experience, you end up with a very precise clash report. Okay. However, as I said, it is cheaper to have more recalls with false positives, right, from an automated BIM tool, right? If you have an automated BIM tool in place, all right, so that does resolving clashes automatically, reviewing automatically, it may lead to more recalls. However, it's cheaper because more recalls ensures that the clashes are addressed. Historically speaking, that's from a litigation point of view. Historically, engineers might be invited to court, okay, to court of law, to explain why engineering code is substitute to manual calculation. That's a reality, you know, and design processes. So they may be invited to stand and justify to the judge why the engineering code that is being used, if something happens or a building collapses or there's a whole chain of investigation. So one of them is inviting the engineering code that is being that the model was used in the simulation. So they will have to explain why this was done as opposed to manual checking, so manual calculations, for example, right? So it did happen in the past. Okay, so such rigor has disappeared because engineering analysis software such as, I'm sure you know, this SAP 2000, structural analysis, are common and integrated with BIM authoring design tools, for example, Revit. So because you have regular checking with cross, because they're integrated, which means they are interoperable with each other, so they can share the models and clash them, and then before it goes into construction. This sometimes leads to professional carelessness or to lazy thinking that someone else will detect the problem, if any. Okay, so if you rely too much on the software and then someone else will detect it, I'm just going to pass it on. No, you have to really pay attention to the clashes. Right. So reliance on software is leading to widening the gap between professional practice of engineering and the statutory requirement that safeguard public safety. So evidence of this has been observed where professional design error is one of the reasons why clash detection is often inevitable. Because it's clash detection ensures that there is no professional design error, right? Because if there's an error, it will be detected, right? Question: should the professional negligence of an engineer be treated as a clash? Okay. And or does this error not lead to more waste? Can you take 10 minutes to think about? Right? I want answers. Okay. Each one of you will provide an answer, please. Try to be engaging. Okay. What do you think? The person next to you can discuss this. So I'll grab a coffee. Bye.
You're laughing at my joke. You're gonna laugh at us. That one's bro, that's not my phone. It's either creepy. That's what I did.
Okay. So, any ideas? Should the professional languages be treated as of an engineer, or it could be architect, engineer, designer? Should be treated as a clash.
Yeah.
Why is that?
Why? Because if this professional language they haven't done their job to the right standards, meaning that it's not going to work. It's not going to align.
Exactly. So standard. You said standard. That's the answer. Standard. If you're not working with standards, you might provide a wrong level of detail, for example, and that lead to a clash. So it is originating as a clash, okay, and it does lead to more waste, okay. All right. It is most probable that manual 2D CAD based coordination of systems will be done by experts and experienced subcontractors, okay. Because if it's experienced subcontractors, if they have a manual, they have a 2D CAD drawing, okay, coordination system, they can still detect clashes, because from the construction drawings they can know whether it's buildable or not. So they can foresee the problems. However, the more accurate BIM-based automated clash detection is, the more accurate BIM automated clash detection might be carried out by novices. Okay, so you know what novices are? Novices are less, designers with less, minimum or no experience. Okay, so this is the best way to do clash detection is using a BIM-based automated tool for novices. Okay, like Navisworks, for example. Right, such novices may be skilled in a clash detection software, but lack one of the more of the following. Any ideas? Maybe. You guys may be skilled at running the software, okay, doing clash detection, flagging them, but you lack one of the more of the following. Okay, any ideas what this might be? Yeah.
Is it how to solve the clash?
Could be, yeah. Could be. New one? So the underlying knowledge and experience of design construction of subsystems. This is design isolation. Remember when we covered situational awareness in the first term? Situational awareness is that you're aware of other disciplines. So you have the knowledge, the underlying knowledge of the construction of subsystems. Most of the time, these people have the underlying knowledge because they're the one to build. Okay, they know. If you speak to a builder, they'll just tell you the problems they faced with the architectural drawings, for example, in the past. They can say, "Oh, it's architects know nothing," because they provide you with stuff we have to make sense of. If you don't provide a detailed step-by-step construction process, then you may not have the underlying knowledge of the subsystem. So, as as an architect, novice architect, as most of us are, we may be genius at running the software, but we don't have the underlying knowledge. So if you take a programmer, they will program the software for you, right? But they don't have the underlying knowledge of subsystems, of construction knowledge. Okay, so if you don't have the construction knowledge, this may lead to inaccuracy in the clash detection. But this, doesn't mean that you will not do it, but it grows with experience. So you build your experience as you get involved in more projects. Okay. The experience is how to seek or interpret the knowledge provided by specialist authoring designers. Right? Can you explain to me what it is? What do I mean by the second point? For example, I'll give you an example. Okay, I'm a BIM coordinator. Okay, I flag up a clash, and the structural engineer, and let's say the plumbing. Okay, there's a problem with plumbing and structural engineering. Let's say a structural engineer will have some of the knowledge in how plumbing is done. Okay, they have some of the underlying knowledge of how plumbing is, the slopes, the sizes, flow rate of, let's say, pipes, plumbing, general plumbing stuff. Okay, so when the structural engineers get involved and goes into discussion with the plumber, or the plumbing engineer, they will suggest or seek interpretation because they know some of this stuff. So the plumbing engineer will not have difficulties making the structural engineer understand because they know that the knowledge provided by the specialist is already there. So there's no problems in communicating. So instead of taking 3 or 4 days to resolve a clash, you may take just a few hours of discussion and then the clash is resolved. So as I said, such novices may be skilled in the clash detection software, but lack the experience of how to seek or interpret the knowledge provided by the specialist authoring designers. Okay, as I said, so if the plumbing suggests something to the structural won't have problems interpreting the information provided. Okay, so that's why novice architects may have someone experienced with them to review clashes with them as well, most of the time. All right. So clash section. All right. This is a survey. Was in 2017, some time ago. It asked industry professionals to think what are the clashes. What are the most important ways to resolve clashes? Okay. Important ways the clash can be avoided or minimized. Right. So 62% answered designers being more careful, accurate with their own model output. Okay. Level of information. You don't have the underlying knowledge of level of information, standardized information. You provide LOD 500, 100 at the detailed stage. It's not appropriate. So there's no construction information attached to the model output. So this is the answer from the industry. Okay, they said designers should be more careful with their model output. Okay, be careful what you issue. Right. The second one, it's the designers co-creating models in real time within the work shared server or common data environment. Okay. Again, second one, CDE. What's the purpose of the CDE? It avoids clashes. As I said, working in WIP using model coordination online, it does help. It's one of the clash avoidance strategies. Now it's coming coming to the surface. You know, working in CDE is part of clash avoidance, right? Especially now you have technology where you can run clashes online. You don't have to do it locally on your local on your local software. That's one of it. The second one is designers working with more information provided by other specialists. Okay. Try to use more information so that it guides you through. All right. Can we take a 5-minute break? Yeah. We take a 5-minute break. Yeah. We'll grab some coffee or come back. Take some fresh air. Okay. Okay, so yeah, so remember when I told you last week that about volume strategy, working with volumes? Yeah. So that's a volume strategy. It's called a tunnel strategy. So it's you know, the pictures. The picture says it all, doesn't it? Yeah. Volumes. Yeah. Can you read the annotations? Yeah. So volume strategy is you reserve volumes for each system or subsystem. Right. This is a tunnel. Okay. It's an example of you know, railway construction. Okay. The volumes indicate systems, right? Which means this is remember, it's part of a clash avoidance strategy. Okay. Volume volumes allow you to reserve spaces without building the systems. So if you say this is where my communication channel volume will be, right? All the communication will run through this volume in here. So any volume intersects with this will be detected as a clash. Okay, that's which means that you're setting tolerance. Okay, between each volumes. Okay, so this is my, let's say, signaling volume. Okay, anything that's to do with signals will go in here. Any intrusion from other volume or any intersection will be regarded as a clash, because we don't want anything to enter this volume, because that volume is reserved to that subsystem, right? This is a volume strategy. So you work in the volumes. One of the ways you do in Revit is when you do a placeholder, right? Try to work in Revit with placeholders, right? Placeholders, you dedicate a volume. It's an imaginary volume, okay? Just reserves the space, okay? A shaft, for example. Shaft, if you do shaft, okay? Anything that intersects the shaft will be detected as a, you know, something intersecting the shaft, okay? So that it's blocking the volume, so that you know what is going through that volume, okay? This is a volume strategy. There's no evidence of its success, but it's good if it can be employed, if it can be deployed, okay? Another one is called pulse scheduling. You guys got any idea of pulse scheduling? No? This is mostly used in manufacturing. You know, because manufacturing, they work a lot with volumes, okay? When they design stuff. For example, when you design an iPhone, the design team will be, iPhone is, you know, it's like smartphone is composed of, you know, multiple layers, you know, different systems. So how do you make sure that the design fits the production line? You do this, you do volumes. Okay, so the screen has a volume. Let's say the motherboard has a volume. Okay, battery has a volume. You know, the casing has a volume. So all these volumes are linked together. Okay, so without having a fault in any of the systems, the screen cannot intersect the volume of the battery. Okay, because you know it's a screen and the battery is a battery. Okay, so this is how you do with volumes. So you do volumes when you send it to the production line. You make sure that when you assemble together at the end of the assembly line, everything fits together. Okay. Pulse scheduling is also used in manufacturing. It's used in manufacturing and is being applied in the construction. Especially, this works well with off-site construction. Okay. Offset construction is important nowadays. Okay, so full scheduling concept used in lean production. Okay, do you know what lean production is? Yeah, lean production with minimum waste. Yeah, including time and resources. Yeah. Lean is a big topic. Okay, lean production. Right, so it is designed to respond to pull or needs of customer needs. Okay, or end users. All right. One of the there was a project as a library, as public library. This was in France, I think. So the council approved the project. Okay, and what they did was right next to the because it's an urban site. Okay, so what they did was they set up the pin-up, okay, in a outside, okay, for the drawings of the project itself, okay, so you can see the drawings, and there is they allow people, passers-by, to comment on those screens. So they would record their comments. So how would they, what let's say if you're a customer, because you live in town, you're a customer of that library, you'd be a customer, so you can give your opinion and suggestions to the on the pinup itself. So that when the designers review the comments, they're responding to customers. So what would you like to use in the library? What would you like to see to use in the library? Do you like the study room? What would you prefer? So things like that. So answering the customer's needs is part of full scheduling. Okay, people won't have to adjust. Because sometimes it's if what I tend to see is people adjust based on what they see comfortable. Okay, so if the seat or the room or the room is not delivering the function, people will have to adjust. But that adjustment may affect how the room performs. Okay, so that's answering the needs of customers. Post scheduling reduces overproduction. Okay, so as I said, when you do pull scheduling, you reduce waste, overproduction. Okay, so if your volumes are not intact, you may have to cancel that production. Okay, only the required amount is produced in every stage. Okay, this system allows a system with little or no WIP. Remember, I said little or no WIP. There's no WIP because what you're doing is you're addressing the issues as we move along. Okay, so not only is WIP, but there's a higher chance in that model that model will be the final model because you're correcting it or you're making changes as you move along. So little, no WIP. Making production process very flexible with almost no waste. Okay, that's the WIP, right? Okay. Pull scheduling is here, all right? That's a push scheduling, pull scheduling. That's construction WIP scheduling, okay? That's the pull scheduling, all right? So pull scheduling, as you notice, is there's a loop, feedback loop at every stage, okay? This is very schematic, okay? It's not very detailed, but this depicts the name pull, right? So when you pull schedule, so you move from process step 1 to step 2. WIP changes any version. You need to, if you produce a new version, you do clashes. Something needs to be changed. Send it back to stage 1, and then before it moves to stage 3. So that's a pull scheduling. So every time you're checking the iteration. Okay. So how pull scheduling can help clash avoidance? After you've seen what pull scheduling is, can you name think how post scheduling can help clash avoidance? Any summary? No? Seems to be out. Okay. Design of different systems is sequenced according to their level of flexibility. Okay. With those systems, having less flexibility, being prioritized. Okay. So, could you tell me what do I mean by less flexibility and more flexibility? Guys, these are important terms. Okay, you will hear them in the construction, in the industry out there, and they expect you to know it. You're not going to have someone sitting next to you and they'll explain to you what is flexibility, model flexibility. So it's one of the things that you have to learn during uni degree. So more flexibility is the level of flexibility is when okay. So let me put it this way. With less flexibility means any changes will have the least impact. Okay, that's less flexibility. More flexibility means more flexibility means less impact on any changes. Okay, less flexibility is difficult to change because it complies to regulations. For example, so someone going to come here and say, this is a room. We have a column here of certain size in the middle. They'll come and say, oh, the architect said, please change the size. I want it reduced. Okay. It is according to calculations, so you cannot change it by mere preference. You see, so there's less flexibility in the structural elements. Okay, structural elements, if they are to be moved, it will have significant impact on the calculations. So you have to redo the calculations and make sure everything works, which means any changes on the structural model will happen, but with minimum changes. You see, because the structural model is built on the architectural model, so they follow the model that is provided to them. MEP, you can change MEP ducting system. However, you cannot bring it. Let's say, I want the MEP system to be lower, and you have the ceiling. So the ceiling is a volume, okay, and the ducting system volumes. If you bring it down more than necessary, they will intersect with the volume of the ceiling, and then you'll have to move the ceiling. And then if you have speakers on the top here, you cannot move the ceiling down because you got speakers there. Things like that. You see, this one here, why it's so ugly, yeah. So less flexibility means the model has, there's less changes, okay, to be made. Okay, that's what do I mean by. That's what I mean by systems having less flexibility than being prioritized. So you prioritize the structural model over others because others can, any changes on the models will have no impact on other disciplines, or not no impact but less impact. Okay, so this is used to determine work chunks and handoffs. Okay, you know what work chunks and handoffs are? Work chunks. Yeah, so we need to deliver certain deliverable work chunk. Okay. Each last designer, this is important, inherits or imports the models released to them into their BIM environment with respect to previous versions. Okay. Is that clear? Yeah. Make sense? Yes. The current designer cannot tamper with other systems, as I said. They must coordinate. There is a hierarchy workflow that you need to work. So they must coordinate, superimpose, all right, their work with the existing work of the last designer. Okay. The last designer who issues the model. That model of last designer will be the model used in the next designer, or the one who inherits the model. Which if the model has issues, you will inherit issues with it. So when you design your model, you design it in a way that it fits the last designer that you received the design from. Okay, and that if it has issues, your model will have issues as well. So, but you cannot temper because there's a something called model originator. Okay, as I explained. Any issues found by designer is raised immediately with the last designer, and it must be resolved before designer continues. Okay, that's a full scheduling. Okay, before it continues, it needs to be resolved. Okay. The ideal result should lead to zero clashes when last designer or the last system finishes their work. Okay. When you finish your work, you're the last. Technically, you would have minimal, zero waste, zero clash, basically, because you already resolved the clashes along the way. So you're doing a proactive. Right. The need for clash detection by BIM coordinator is therefore minimum, right? Since all issues of their resolution have been taken care of by the last designer and his predecessors. Right. So, in perspective, okay, clash detection is actually a reactive. It's after the fact, okay, reactive to the fact. BIM coordinator does the clash detection after the issues have been piling up, okay. So that's a reactive. So you're reacting to the clash. However, it's as I said, a clash detection is reactive to design model management. BIM coordinator manages or aggregates the BIM models, okay, from different disciplines in order to detect clashes and coordinate the final model, right? Clash avoidance is, however, proactive. As I said, the design team can either, right, adopt a workflow. As I said, workflow. Remember, earlier this morning, I said adopt a workflow sequence, right, which has been tried and tested in manufacturing. Okay, all scheduling has been tested and used in manufacturing. Or you can use volume strategy. Okay, volume strategy works well because you work with volumes and shapes, and you can still use it. There's no evidence of its success, but it still delivers the clash avoidance. Right. So, in summary, right, we're going to go back to steps of the clash detection. Okay. A clash is an intended undesirable conflict, intersection between two volumes, all right, or two shapes or objects. Clash detection is also regarded as a quality control. It improves productivity, right, and reduces waste. We've seen soft, hard time-based clashes. Okay. We've seen why clashes occur. Algorithms for clash detection. We've just reviewed them briefly. We've seen also precision, rate of recall, false positives and false negatives. Clash detection versus clash avoidance, what is the difference? We've seen volume strategy and finished by whole schedule. In summary content, do you have any questions regards to what we've covered? All right, some of it was covered last week, okay? And for those who attended last week, any questions? The content? Anything? My question? Okay. So how many of you have done? Okay. How many of you have done the lab handout from last week? done, yeah? Yeah, I mean here. Yeah. You finished it, yeah. Sure. You won't be able to do the next task if you haven't finished it.
Is it the two things that you sent out?
Yeah, I said the sectioning, model section and viewpoint. Yeah. Exploring the model. Anyway, so we'll do Clash Detective today, okay? I want you to download the Clash Detective, okay? The zip file. Extract it. And open the PDF. And those who haven't done the previous tour, please do it because otherwise it's difficult to do the. You might be able to get away and do it, but it's good to explore the model first. Okay, so I want you to do this. Open the handout. Okay, you've got this is the handout of Clash Detection. Okay, and we have models along with this file. Okay, please use these models to run the Clash Detection. Okay, that's the handout for the second part of the lecture. Okay. You get the attendance sheet, yeah? Signed it, yeah? Signed it. Yeah, okay. In industry there's different names. So, sometimes, for example, in manager, they call sometimes you have an extended role. Extended role. Say, for example, it's providing you build execution. You check the flash tips, you check the report, you check the other disciplines, you federate, you check the workflows. You're going to extend it as a manager. But BIM coordinator sometimes does only the coordination process. People sometimes do in industry they call design digital designer. Digital designer is a broad term because it doesn't define a specific role. You see, it could be because there's a drive towards construction is shifting toward digitization. So there's minimal paperwork. You have more people working on computers, technology. You may call them all digital designers. You could be an architect and a digital designer at the same time because you're performing a role. You're doing the modeling using technology. So digital, right? Sharing information digitally, that's digital design. So anything that has digital in it, it could apply to a digital design. So there's no specific role. Yeah, so you may find when you do job prospects, you may find different names that they call BIM as a different name. model coordinator. Sometimes we need a model coordinator. They don't mention it, but it's model coordinator is it needs to have been been knowledge. So
And I think digital application.
yeah. Yeah, so digital engineer could mean anything. Anything that has to do with engineering. Okay? Because nowadays, who works with paper? Or who draws on paper? It's all digital, so it's a broad term. I think there has to be some standardized way of giving naming the vacancy. See, because it's job and role. You see, because you cannot say digital engineer. It has to define a certain role. They need to give you key responsibilities. So when you look at the key responsibilities, you'll have an idea what digital engineer would do. See, engineer could be infrastructure, could be civil work, could be structural analysis, could be foundations, could be anything. Yeah, anything. There's no specific part. Sometimes they do this as a broad, and then you can specialize in that. So just to attract more candidates. Because if you widen the scope of the title, you got more candidates, so you can explore more talent. So that's how they do it.
No, because I'm trying to see it. That's why. And you create that structural one and then put it in the market. That's what I'm doing, right? Where is it?
Okay, so if you can crack down on partial. Please, yeah. No, it's just different exercises. Have you been following what I was saying? You go to modular information. This one. Partially, you got to pay attention. So when you say stuff, please do that. You cannot start with opening a file, so just read the PDF first, scan it first, and see what is required, and then you do it. Right? It all builds up on the lecture of today. So last week. last week, but last week was different.
Oh, you don't have to. Oh,
This one is for class reduction. It shows here.
yeah, yeah, consultation, yeah.
No, it's not. What? Yeah, one minute. It was. I don't know. What? Huh? Yeah, exactly. How to type in the name? Huh? Yeah, I done it right. Babe, hard thing. This way will include all things, right? Dude, all these things are fixed. Thing. Oh, it's here. Scroll down. It doesn't say Stuart. No, it says item at the bottom. Can't you see? No, right at the bottom. Yeah, there. There. Huh? There it is. Yeah, it's here. This bit.
Oh, okay, I get it.
Says.
Thank you to look in the direction.
Wow. In the results page, select
This would be the yeah, as I'm in this house.
have a look at
So why did I need to fly?
I've always smelled really bad. I've never used that. You've only got to look at something. It's nothing to do with it. Are you sure? Yeah, but you doing well in this stuff. So why was he saying all that shit? And then it really funny.
The thing is, he wants to be made mad of what he was up to. Pumpy wants to be made mad.
Who's bigger than the
Got it there, right beside me.
I love it, however. He's basically like that.
You don't even want to be there. Before it was this. Tom's better, but Tom's in the pretty side. Huh? Tom's better, but Tom's in the pretty side.
He was.
Oh, he was?
That was a bit controversial.
It's just, you know what, his, like, his first touch is just too much.
So you have to keep every time you open windows and
They were all just
line up. So if you want to stick to the same working
now
section,
it's
you want
all that.
the windows to stay the same after you open. You can go to view, and now there's a save workspace. Save workspace, you will save this. Okay? So every time you open it, you go like that. So saving the workspace is a template, and you see the XML file. Okay? You can have it saved here. You can name it as flash section workspace, and then because timeline is different than workspace, so you work with different. So this is how you save. It makes it easier without having to play around with windows.
For the general one.
Yes, let me show you a trick, okay? So yeah, so sometimes you see windows can be problematic. So you open windows here and here. If you're working with clash detection, if you press clash detection, you have windows in here. So you will need that. So every time, so to avoid opening windows over and over again when you close a file, you can save that and name it as a clash detection, because the clash detection you only need this window, probably not one. So in order to save this, you can go to View and Save Workspace. Save Workspace. So it saves the window, so you don't have to open the class section again. So you straight away see it. Just have it in the workspace. Yeah. Go back. Yeah. Have it here. It should be in workspace. So this is how you organize your workspace in Navisworks. So every time you do something,
It's
you
literally
save it as workspace.
yeah.
No, there's something. Check. Please check the. Check the. Yeah. Up. What do you see? Is it 1 meter? Yours? Add a test. Yours? That's it. That to be sharp eye, okay? Run test. You run it. You have to select expand. No, you have to. You need to have two different models, okay? Are you doing arch versus arch? You have to know what it's asking. No, it's asking architecture versus structural. Okay, so you have to append the model. So please read it again. Yeah. This is how you open it. You have to follow how you ask you to open it in the handout. Read the handout carefully. Append, okay? Append, not open directly.
Have you pressed the second button? Yeah, that's it. Structural column.
Okay, so let me show you a trick, guys. Okay, so for example, when you work with Navisworks, there's a tendency in people industry, they work with two or more screens. Okay, They don't just stick to one screen, okay? Because it's, you know, the windows are, when you open clash detection, for example, with a timeliner, and you're looking at the selection tree. Now the windows, you know, the model window gets smaller, so it doesn't allow you to see the model, you know, properly. So so you work with more. Is advisable to work with 2 or more screens, okay? The other thing is that if you want to, let's say you're doing a clash detection, okay? I'm having my window here, okay, pinned in here. My selection tree is in here. I can probably place it somewhere here, maybe, okay? So I want to have them in on the side. Depends on the work preference. So if I want to have this window to open regularly with me because I'm working on a clash detection, what you can do, you can save the view like this without having to do this again, you know, pin the windows and on. So you go to View and you select Save Workspace, okay? Now it will save the workspace. You can name it Clash Detection Workspace, okay? Right? And then you save it, okay? So next time you open, it will open the window like this, okay? Without changing the windows and closing them, okay? That's a trick, yeah? There's another problem with the unit, okay? Changing units in Navisworks, okay? Make sure you work with millimeter. It's either millimeters or meters, okay? Make sure the tolerance is set at the right number and the right unit. If you don't do that, you may end up with 0 clashes. So you may not. In order to change the units, I think if you go to, options, general, maybe model tools, somewhere in here where you can change the units. Okay, let me search. Save. Okay, so guys, all right, so let me show you the units so that you don't get confused, okay? You're working with millimeters, you go to, or you change the units, okay? Sometimes I've seen that some of you have meter in here, and then 1, okay? You have to be careful. It's millimeters, not meters, okay? You're working with meters, all right? In order to check the units, you go to Options, okay? Interface, okay, expand interface. Go to Display Units, right? Now this is where you find we can change the units, okay? Now it's meters. It's advisable to leave it in meters, and if it's millimeters, it's 0.001 meter. It's not 1 meter, okay? These are decimals. Decimal, you can maybe 3 here. So this is how you change them, okay? units. Units in here. Interface. Display units. So we're changing. Yeah, yeah. Keep it meters and then convert. Convert this to 0, 0, 1. So if it's 1, it's 1 millimeter, not meter.
But what about that importing the structural file? Does it show the,
Say again?
does it show the structural file?
You have to import the structural file. So you've got two files, the architectural and structural. So you have to import the structural file. Can you read? Can you read it through the manual?
Full instruction B.
Go back to the file, please. The manual. What does it say? Can you read? In the selection A pane, select. Alright, so read here. Okay. Go up. Go up. Go up. Go up. Okay. Now, what does it say? A pen. Can you see it? Yes, focus. Yeah, focus. Focus. Yeah, focus. Yeah. Yeah.
Yeah, he was telling me that was good. So he didn't care when it was.
Okay.
I'm on the next one, and it says, because of UC, select color.
Select what? Selection should be one.
Under UC, select color.
Select.
That's what it is.
Home is the. Is home. You see home?
Oh, okay.
Yeah, it's just positions in the model. Yeah. Just fix the model to you.
I didn't know it's called UC.
It's probably dark, so sometimes people change it to white so that they can see. But the home tab is the home scene. So this is a view and this is the home. It's similar to when you do Revit. You see, when you press this sentence to model. Yeah.